This is the first lecture of two. We are going to talk about material balances, non-reactive systems, part one. So there's going to be four days of chapter 4. And so there's 2 lectures as part of the first day, which I'm going to give you the first of the 2 now. So here we go. We are going to begin process balances. Now you've learned all the basic fundamental relationships that you need to know, and now we're going to start working with processes. So in this lecture, we're going to learn the basic types of processes, mixing processes, splitting, separating processes. And we're also going to learn how to write balances, material balance. And there's going to be different types of material balances. We'll have the differential material balance, integral material balance. The different terms in the balance equation include input, output, generation, consumption. And I didn't add it on here, but there also exists accumulation, which we don't consider much in this course. We mainly work with steady state processes in this course, but you will have to work with accumulation in your future classes. And we are also going to learn about determining the degrees of freedom in our process and the number of independent equations. So we're going to cover all of these in this class. So the first thing we want to talk about is the different types of processes. There's 3 different types of processes. There's a batch process. In a batch process, you put all them, you charge the process unit with the feed. So it's put in one lump. And after a period of time, the process is complete and you take it out. There are a number of batch processes in real life. A continuous process, on the other hand, you feed in steadily the feed and you remove the product continuously. And there, you will be learning about continuous steady state reactors, CSTR. An example of a CSTR in bioprocessing is a chemostat. And then we have a semi-batch process where you may begin by charging with some feed, and after a period of time, you may add additional feed. And that's why it's called fed batch or semi-batch. There's different reasons why you would run a process like this, mainly because you have a catalyst and you don't want to poison the catalyst by putting too much of the feed in at once. Okay, so we can also classify the process as steady state, as I mentioned, when there's no accumulation or depletion of material in the process. Actually, not depletion, when there's no accumulation of material in the process. If it's unsteady state, you can have depletion or consumption, but it has to not change with time. Okay, so an unsteady state process means that one or more process variables changes with time. So if the process variables are steady with time, then it's a steady state process. Okay, so here's the general balance equation. We have here we have some flow in, okay, and as we're going to see that this is called a differential balance because you have a flow rate. You have moles per second, and you have different species, and you can write them in terms of mole fractions. You can also write them in terms of the total moles going in. And we have a similar situation of the materials coming out. So we label it F dot out. And it's helpful to stay consistent by using these same variables because these are kind of standard variables. And just to note that all the mole fractions, if you sum them up here in this in a stream, they will sum to 1 in the same and the outlet. Okay, so the terms in the balance equation are input, generation, output, consumption, and accumulation. And input is anything that enters through the system boundaries. All right. Here we have a stream F in. This is the input. Generation is anything that is produced within the system. So let's say a reactant goes from A to B, then B is generated in the process. Okay, output is everything that's coming out of the process. It leaves through the system boundaries. And consumption is not produced, it is consumed within the system. Okay. Okay, so let's say A goes to B, then A is consumed and B is generated. Accumulation is if you have buildup of material within the system. Okay, so you can have generation but no accumulation if everything that is generated goes into the output, which is the case with a steady state process. Okay, so the other type of balance is the integral balance. Here, instead of talking about a rate, we talk about a total number of moles. Again, we have the same possible terms in the balance equation. And so everything's the same as it was on the previous page. It's just that we measure the process during some finite time. So there's no time term in the flow of material into and out of the system. Okay, so we've already seen this one now. We have a simple input and a simple output. Just stuff goes in, stuff comes out. That could be a chemical reactor. Like A goes in, B comes out. And we can either write it in terms of a molar flow rate. This is convenient when you have a chemical reaction. Okay, because chemicals react according to moles. If you are doing a separation or mixing process, it might be more convenient for different reasons to use the mass flow rate, because there is no change in moles in the process. So basically, the mass in is the mass out, and there's no change of substance happening, which is when you want to have things in terms of moles. All right, so here's an example of a separation process. You have a flow in with A, B, and C, and you have two flows out. Perhaps it's an evaporation, perhaps it's a distillation, but basically you're separating on some basis, you're separating some composition of A, B, and C with a separate composition of A, B, and C. Maybe to increase the concentration of one of the species in your stream, you could perform a separation process. Mixing process, this time you have more than one stream entering, but you mix it together so everything comes out in one stream. Okay, so we are ready for the first quiz. And I suggest that you consider here, what you want to do is write balance equations. Write the balance equation. So look back a few slides at the general balance equation. All right, and as you can see here, we have a separation process. Okay, and in a separation process, you have no chemical reaction. Okay, there's no reaction taking place in here. So your balance equations are going to be input is equal to output. All right, and I think you probably can handle this.